We have all seen these incredible, sometimes totally wild images that AI can create, but have you ever stopped to wonder how it actually works? How does a machine go from a simple line of text to a complex, detailed picture?
Well, it turns out there's not just one way to do it. In this explainer, we're going to break down the two main philosophies, the two big methods that AI uses to dream up a picture completely from scratch. So here's our game plan. We'll start by looking at the two major approaches. Then we'll dive into how each one works. After that, we'll see what happens when you combine them. And finally, we'll talk about what this means for the future of AI. All right, so today there are really two main ways an AI model learns to create something new. And this applies whether we're talking about text for a chatbot or, pixels for a picture. Think of it like this. On one side, you have the sequential artist. This AI builds a picture piece by piece, in order, kind of like laying down tiles in a mosaic. On the other side, you have the master sculptor. This one starts with just a block of random static and carves away the noise until an image appears. Now, what's fascinating is that something like 90% of today's image generators, they're sculptors. But the very best text generators, the LLMs we use every day, they're all artists. They think sequentially.
Okay, so let's dig into our first method, the artist. The whole idea here is to treat a picture not as a single thing, but as a sentence that needs to be written out.
See, this kind of model doesn't look at the whole canvas at once. Its entire job is much simpler, but also really meticulous. It just looks at the little patches of the image it's already generated, and then predicts what the very next one should be. It's a very careful step-by-step process. But here's the catch. You can't just feed raw pixels to a language model. It wouldn't know what to do with them. So first, the image has to be translated into a language it understands. A special kind of neural network acts like a universal translator. It takes each visual patch and turns it into a single, unique number. Suddenly, the entire picture is just a simple sequence of numbers. And these numbers have a special name. They're called vision tokens. This right here is the critical link. Each number acts like a word in a dictionary. But instead of representing a concept like tree or sky, it represents a specific little visual patch. The image has basically become a sentence that the AI can read. And what's the best tool on the planet for understanding and predicting sequences? A large language model, of course. So by analyzing millions and millions of images alongside their text descriptions, the LLM just learns the patterns. It learns that a prompt like "a cat wearing a hat" corresponds to a very specific sequence of these vision tokens. It literally learns how to write the image, one token at a time.
Okay, now let's switch gears and look at the other approach. This one doesn't start with a blank canvas. Oh no, it starts with pure, unfiltered chaos.
The whole philosophy here is totally different. It's not about building something from nothing. It's about finding a hidden image inside a blizzard of TV static. The AI's job is to take all that randomness and, step by step, just clean it up, revealing a clear picture, just like a sculptor carves a beautiful statue out of a rough block of marble.
The way these models train is pretty wild. It's shown a perfect, clean image, and then it just watches as that image is slowly destroyed with noise, layer by layer. Then, its job is to learn how to do the exact opposite. You give it the noisy image and a text prompt, and its only goal is to figure out how to undo just one tiny step of that noise. By repeating that denoising process over and over and over, it essentially reverses chaos to reveal the hidden image, all while being guided by your text prompt.
So what we have here are two totally different ways of thinking. The artist is a bit slower, but because it's built like a language model, it has this deep semantic understanding of things. The sculptor is way faster and is just brilliant at creating those gorgeous photorealistic details. And this, of course, leads to a really big question. What if you didn't have to choose? What if you could combine them?
Well, that's exactly what some researchers have done. There's a new model called GLM Image, and it creates this super powerful hybrid, basically getting the best of both worlds.
And you can see it right there in their research paper. They say they decided to adopt a hybrid architecture, combining the two. They didn't choose one path, they decided to merge them because they saw each one had something really special to offer. So think of it like a two-person team. First, you have a massive 9 billion parameter autoregressive artist that thinks really hard about the prompt. It uses its deep language skills to create an intelligent plan, that sequence of vision tokens we talked about, which acts as a super detailed blueprint. Then, it hands that blueprint over to a 7 billion parameter diffusion sculptor, which takes the plan and executes it with stunning, fine-grained, photorealistic detail. It's a brilliant division of labor. And here's where you really see the benefit.
because the first part of the team is basically an LLM. It can understand and reason about text. It knows what letters look like, how they form words. The diffusion part can then draw that text with a precision that pure diffusion models really struggle with.
And the data backs this up, 100%. If you look at this benchmark, which measures how accurately models can draw text inside of an image, the numbers speak for themselves. GLM image is right there at the top, clearly outperforming the others. That hybrid mind is just flat out better at this very specific knowledge-heavy job.
So what's the big takeaway here? This isn't just about one cool new model. It really points to a much bigger trend in how we're starting to build artificial intelligence. We're seeing this really important shift from competing architectures to collaborative ones. It's not about asking which type of AI mind is better anymore. The real question is, how can we get different AI minds to work together on the same task, with each one bringing its own unique strengths to the table?
And this versatility proves it's not a one-trick pony. The combined approach makes it a much more flexible and powerful creative tool all around. It's great at complex editing, at preserving someone's face across multiple images, all sorts of advanced tasks.
Which, of course, leaves us with one final, big question. This really suggests that the future of AI isn't about finding a single perfect model to rule them all. Instead, it might be about building a team of specialists, different kinds of AI intelligence, all working together to create something far greater than any one of them could achieve on its own.